All right. So we're dealing with more factoring still, all of our different options that we started talking about yesterday. So today, though, we're going to hit up on some of these things again and kind of look at how this works. So like I was saying a moment ago, whether there's 2 terms, 3 terms, 4 terms, first job always, golden rule. Do all of my terms have something in common? If they do, I need to take that out first. So with that in mind, number 6, do those 2 terms have anything in common? V. Okay, they both have a V I can take out. Okay, not V squared. The second term doesn't have a square, but I can take out a V. And then let's see what we've got left to put in our quantity, our set of parentheses. 5V plus 6, because 5V times V would be 5V squared. 6 times V is 6V. And I know I'm done in this case because unless there's a squared term, unless there's a quadratic left still, I can't do anything else. So sometimes it may just be factoring that common term out and that's all I get. That can happen. Okay. But as we go along, we can get some other twists and turns that happen to start coming in here. So like let's say we get to 8. Now 8, we've got a couple of options. Oh, do all 3 terms have an A? No. So I can't take out a common term this time. But I'm glad you were thinking about that right off the bat because we always should. But 4 isn't a multiple of 3. But again, I like what you're thinking.
Well, I don't know, man.
I can't take anything out this time. So you're like, okay, well then what do I do? Well, I have options. I have 3 terms here. Nothing was in common. Okay, is my lead coefficient 1? No. Okay, so here I can guess check, or I can go to slide and divide. Okay, that's an option. So one of my options would be to slide that 9 down. And again, when we slide it down, we mean we're going to multiply the 9 times the 4. And then we're going to factor what's left here. Now remember, back from when we were doing diamonds, we've been doing them for a while now, we're trying to find 2 numbers that multiply to the number on the end and add to get the number in the middle. So I kind of look at my signs and things to see if there's any hints that are involved here. So I look, I'm like, hey, the 2 numbers are multiplying to a positive, but they're adding to a negative. So they're both going to be negative. Nice. So then I turn my focus to the actual numbers. Okay, 2 numbers that multiply to 36 are going to add up to 12. 6 and 6. Now, be careful. Don't circle that and think you're done. Because if I tried foiling that back out, I'm not going to get this. Remember, this process is called slide and divide.
Divide by 9.
Okay, divide by 9. But I also have to be careful. Because we've talked about this before, and we've said, hey, when I'm doing these, if I do the division and it doesn't come out nice, I slide it back to the front. But hang on, there's one other part to that. We've got to make sure the fraction is simplified completely. So in this case, I'd have to reduce the fraction first. And I'll show you in a second here what will happen if you forget to do that, because it doesn't turn out very good. Once I get it completely reduced, if it's still a fraction at that point, then I take the denominator and I swing it back to the front. And if it's the same thing, I even could just write it as 3a minus 2 squared. Either one of those would work. Now, some of you may have kind of gotten stuck with me back when I went from here to here, and you're like, well, but if it's slide and divide, why couldn't I just, slide the 9 back in front and say I'm fine and good? Well, that's a good question. So let me do a little side thing here to show you why that wouldn't work. If I slide the 9 back in front right away, okay, and then I went and said, maybe I'll multiply that out to see if this works or not. So let's say I was like doing a box or foil or whatever it was. Very quickly I'm going to see, wait a minute, something's not right here. Because I do that first box and I'm like 81a squared. Wait, that's not 81a squared, that's 9. something ain't going right here. This something I got to go back and look. And then hopefully you'd remember, oh yeah, I got to reduce it. Okay. So slide and divide is one option. My other option, which goes faster, but I've got to learn to recognize it, is look at your first and last terms. They're both perfect squares. So if that's the case, what I can do then to kind of make this go faster is, what do you square to get 9a squared? 3, so 3a. Because I square 3 to get 9 and a to get a squared. What do I square to get 4? 2, and then you just steal the sign from the middle. Same thing. Either one works though. This isn't always just about speed, it's about getting it right. So in this case, either one of those is going to get me to the right answer. But again, it just depends on how comfortable you are, how much practice you've had to recognize some things like that. Okay, because slide and divide will always work with my 3 termers, or my 3 my trinomial terms, excuse me. Okay, then we get to 10. 10, did those 2 terms have anything in common? That I could divide out at 25 and 9? No. But they do have something special that they do have in common. They're both perfect squares. So, I'm like, okay, so what? Well, if I don't remember the pattern for perfect squares, how I can factor these, I go back to my sheet. Okay, difference of squares. Oh, so it's just what do I square to get each one? And I use a plus and a minus. Okay, so what do I square to get 25b squared? 5, so 5b, 5b. What about 9? 3. And I use one that's plus and one that's minus. And it doesn't matter which order I do them in. But I got to know the pattern to make this work. Okay? Some of you will look at this, and I've seen people do this before. They think it's like solving for some reason. They put equals in there. There's no equals on these. Okay? We're just factoring. And I can't just take a square root and write 5b3. That doesn't work. Okay, I've got to get used to the patterns. Use that sheet until you get used to those and until it makes it a little bit better for you. Okay. Issues so far on the front, because to be perfectly honest, this stuff's more of a review from some stuff that we've done before. Okay, so far. All right. So to the back, this is where the new stuff starts to pop in. So we're going to roll down to 16. It's going to let me knock a couple things off here. Okay, so 16. Do those 2 terms have anything in common? You're like, maybe. Okay, if I'm not sure on the numbers, let's see here. Let's try some small numbers here. I don't think, yeah, 2 is not going to work. Okay, let's try 3. Okay, 3 goes into 375. Let's see if it goes into 192.
Is there such a thing called cube squared? Cube, like the cube sign, like the squared sign?
There is a cube with difference or sum of cubes, yes. And I think we're actually going to get to see that here. Now, I just noticed that 3 goes into both of these. So, let me write this down. Okay, notice I didn't just divide it and leave it as that. The 3 is still part of my problem. I just put it on the outside. So I look at this and I'm like, okay, I haven't remembered seeing this before. This is kind of weird. So I start looking, I'm like 125 and 64. Look at my sheet. Oh, 125 and 64, they're perfect cubes. Okay. Notice also what I've done on my sheet. I went ahead and wrote what you cubed to get each of those numbers. Because that way, when I start to try and use these in my patterns, I'm going to have the number right there. I'm not going to be sitting there going, I don't know what you cubed to get 64. I don't know what you cubed to get 216. I'm going to have it all right there for me to make this a little bit easier to work with. So when I do it that way, I go, okay, but I still don't know how this cubes thing works. Well, I keep looking around on my sheet a little bit and see if this is going to help me out. So I start looking, and I'm like, ooh, there's cube patterns over here. So let's see here. Cubes, there's a plus in the middle there. So plus. So sum of cubes. Okay, what's all this A and B stuff? oh, it's what do I cube and what do I cube? Okay, let's put this over here for a minute. What do I cube to get 125? 5. And then I cube a to get a cubed. So I'm just writing down what I cube to get each thing first. And then what do I cube to get 64? 4, because they're not squares, they're cubes. Be careful.
I forgot. Why'd you divide those by 3? You just felt like it?
Because my golden rule says if there's any common terms, I take them out. Since these are both divisible by 3, I need to take that out. And it also helped me in this case because then it turned them into cubes, which I can actually break down now.
That's going to be hard for me to figure out.
Well, but that's why we got the help sheet. So we can kind of get you some assistance on that stuff when we're starting these at least. Okay, so once I get that set and I see what I cubed to get each, I'm going to look at my pattern here. So let me pull my pattern up. So the pattern says I take my first term, and then I'm going to do plus my second term. So you see why I wrote those out, because that's my first set of parentheses, actually. And I always use the sign that was in the middle of that first set of parentheses. So if this was minus, I use minus. Since it's plus this time, I use plus. And then I kind of start rolling along, like, okay, how's this work? You square the first term. I'm going to square the 5 and the a. So 5 squared is 25. A squared minus, because these two signs will always be opposites of each other. Okay. Multiply the two parts together. So multiply 5a times 4, which is 20a. And then plus my second term, 4 squared, which is 16. Okay. It's a pattern I have to get. There's no like long way out, like a slide and divide or something I can do with this. This is one of those I have to be able to use the pattern, which is why we're going to get some practice between doing yesterday's sheet, which some of you may have skipped because there was some stuff you didn't get. I get that. And then working on some of them today. Now, I want to do another one of these, though, because you're not going to have something that you can take out that's in common every single time. So, for instance, let's go back to 13 and kind of see how this works. And I'll keep 16 on the screen here so we sort of have something to work with. Okay. This time, I don't have anything in common that I can divide out. And that's going to have, oh, and I almost forgot that down here. That's bad. That part that I factored out that starts part of my answer, I got to have that in there. So if I'd have forgotten the 3, that would have kind of hosed me over a little bit. So I got to remember that part. Okay. But 13, I don't have to worry about that because, well, I don't have any common factors. So I cube 1 to get 1. That makes sense. What do I cube to get 8? 2. Okay, and I also do the x because x cubed gets me back to x cubed. And I'm going to follow the pattern just like I did on the last one. So this time it's a difference of cubes. So it's 1 minus 2x. Because what I'm asking is, what do I cube? I didn't change it. I just went ahead and said, what do I cube to get each of these? Because I'm working on parts to be able to work on my pattern here. So it's basically, what do I cube? And I can take that from my list. So once I get here, I'll go, okay, so it's 1 minus 2x. Square my first term. Change my sign. So the minus will become plus. Multiply the two terms together. 1 times 2x is 2x. And then plus my second term squared. And again, I got to square the number and the variable. So 4x squared, and
Where'd 4 come from?
Okay, I'm squaring this whole thing. So let me break it down.
Square it there and you write it squared?
Yeah, here's what I'm doing. Let me get my pattern, keep it up here. And instead of just writing it out that way, I'll literally write out everything I did here. Okay. So I did a plus b, so I had the 1 minus 2x. Then I squared my first term, so I squared the 1. Then I did 1 times 2x. I multiplied my two terms together. And then I squared my second term. So 1 squared is 1. 1 times 2x is 2x. And 2x squared, I square the 2 to get the 4. And I square the x to get the x squared part. Okay. But then the nice thing with these is there's never any little extra thing at the end I have to do or factor something out or something like that. All I'm going to do is that's my answer once I get there. So that's what numbers 14 and 15 are also going to work like for you. 13 and 14 are real similar. There's nothing in common to factor out. 15 and 16 are similar because there's something in common that you have to take out. Okay. So then, one more thing, and then if there's something we got to go back and look at some more, we can. That's not a big deal. Down here at the bottom, now this is new stuff. We got 4 terms we're working with. Okay. Nice thing with 4 terms is we don't have to worry about the what's there in common thing because you're not going to find anything. So you're like, okay, how's this 4-term thing work? Okay, factor by grouping. Group the first 2 terms and the last 2 terms. Okay, so I put some parentheses to group them. I can do that. Then factor out the greatest common factor of each and finish factoring. Okay, so what I'm going to do is I'm going to do these part at a time. I'm going to cover up that last part. I'm going to look at this first part like it's its own problem. So what do just those 2 terms have in common? Okay, they both got a 7. 7b squared. Nice. Okay, I'm always going to take the smallest exponent when it comes to my variable stuff. Then my job becomes to see, okay, well, what's left over that's going to go in the parentheses? So I'm like, okay, let's see. 7 times what is 56? 8. And b squared times what gets me to b to the 3rd? B. Because again, we add exponents when we're multiplying. Now you start to look at the second part, you're like, well, there's really nothing there. I mean, I've already got 7b squared here, and it's 7b squared there. Right, but I do notice it's a negative, and I always have to hold the place with something. So if it's the exact same thing, I'm going to hold the place with a 1. Because 7b squared times negative 1 would be negative 7b squared. So here's how this works for the rest of the problem. If I do this right, when I switch up here, when I get done, my sets of parentheses should be the same. So we're going to have to check this out. So on the second pair, what do they have in common? 3. Okay, so I'm going to pull a 3 out. So 3 times what gets me to 24b? 8b. So far, so good. 3 times what gets me to negative 3? Negative 1. Okay, that's how I know I've done it right. If those end up being different values, something went right. I didn't take out the right common factor. I messed up a sign. Something went wrong. But now to get my final answer, I got one last part. Okay, the common set of parentheses you have, that's half my answer. The other half of my answer is just writing down the greatest common factors that I pulled out. And I'm set. And it doesn't matter which order. If you write down the greatest common factors first and then that common set of parentheses, that's okay.
You did what?
Okay? The common set of parentheses that I got when I did my greatest common factor, that's part of my answer. And then the other half of my answer is just taking that stuff I pulled out, the 7b squared and the 3, and putting them together and making that a set of parentheses. Because then if I were to box that out, I'd get the original problem back. And I can always double check that way if I want to as well. But it always is going to be that way. So I want to look at 18.2, and then we'll kind of, again, we're going to take a step back, kind of see where we're at, how we're feeling with things. So I get here. And again, we're only doing 2 at a time. If we try to do all 4 terms, we're not going to find anything that's in common. What do those first 2 terms have in common?
And
What? 4n squared. So, what does that leave me in the parentheses? Okay, 4n, 4 times 4 is 16, n squared times n is n to the third, plus 3, because 3 times 4 is 12, and I already have the n squared part. So if I did this right, now you start to look at the second one, you're like, wait a minute, Harty, they don't have anything in common. It's just like 4n plus 3. Yes, nicely played. If there is nothing that you see in common, we have to pull out something. So pull out a 1 if you need to. And if you multiply by 1, it basically just leaves those exactly the same. Okay? Same parentheses, that's a good sign. Because then again, my answer is just copying that part. And then those greatest common factors are what I've got left. Issues, because again, I've got keys up front. All I ever ask is that you've tried it using one of the examples right next to it to see if you can do it. And then we check the answer. If it's not right, let's talk. But don't come up with blank and go, try something. Okay, keep your sheet out. Keep working with that. We'll see this again coming up because we've got the unit quiz/test coming next week. So we'll see that again there. But if you've got some issues, let me know and we'll get you set with those.